Hi everyone, let's solve this problem. Pacific Atlantic water flow. There is a M cross N rectangular island that borders both the Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches its island's right and bottom edges. The island is partitioned into a grid of square cells. You are given a M cross N integer matrix heights, where heights of R comma C represents the height above the sea level. Let's consider this is the cell. This is representing height of 5 from the sea level. The island receives a lot of rain, and the rain water can flow to the neighboring cells directly north, south, east, west if neighboring cell's height is less than or equal to the current cell's height. So let's say, for example, this is the cell. It can flow towards the top, bottom, towards the right and left. That's what they are saying. And it can flow only when the adjacent cell has height lesser than the current cell or equal, right? If it is 5 here, if it is 6 or 7 here, we cannot flow here. If it is 5 or less than that, we can flow towards this. That's what they are saying. Water can flow from any cell adjacent to an ocean into the ocean. Return a 2D list of grid coordinates result, where result of I is equals to R of I comma C of I, denoting that the rainwater can flow from the cell Ri comma Ci to both Pacific and Atlantic Ocean. Let's write couple of things before we. So at particular cell, it can go in 4 directions. If this is R comma C, it can go till R plus 1, R minus 1 comma C, R plus 1 comma C, R comma C plus 1, and R comma C minus 1. These are all the directions it can flow, and a particular cell can be in the answer only if cell exists in Pacific and cell also exists in, like, cell can flow towards Atlantic and Pacific Oceans. And the other thing which they are mentioning is that if any cell can flow to the ocean if it's at the borders. So in that case, first row can flow, last row can flow into Atlantic, first column can flow into Pacific Ocean, and last column can flow into Atlantic Ocean. That's what they are saying. And if I am at a particular cell, I can only flow to the cells which are having the lower height. These are all the requirements they have given. So now, instead of starting from each cell, what are we going to do is, we are going to do a reverse action, wherein we are going to assume that the water at this particular row can any which ways flow to Pacific Ocean. Same thing with respect to this column. So now we are going to check, we are going to go through the every cell from here to see if we can flow to that particular cell. So if I'm starting at this cell, I'm checking if I can flow to this cell. That, and if I'm starting at this cell, if I'm able to reach its adjacent cells, and it can flow in 4 directions. So we will check in all 4 directions. If we are able to flow to that direction, and if the Pacific Ocean is flowing to a particular cell, we will insert into our Pacific Ocean set. If a Atlantic Ocean is flowing to our particular cell, then we will push into Atlantic Ocean set. And if the cell is contained in both our Pacific and Atlantic Ocean, only then we are going to put into our answer. So now let's try to code it up. We will understand it better when we code it. So yeah, these are heights, rows, columns, and we already have decided the Pacific and Atlantic sets. I have declared result, and we will be returning the result here. So this is nothing but we will have DFS. I will define a function DFS, constant DFS. Inside this, it will accept row, column, visited array, and previous height. these will be our parameters which DFS accepts. Now in this case, we will pass heights of 0, C. Whatever is the cell, I am passing its height. So what should I pass here in this case is, we are taking the 0th row. So it's in 0th row, it is any which was flowing to Pacific Ocean. So I will be passing my Pacific variable. And for the last row, I will be passing rows of -1, C, and this row is flowing to Atlantic Ocean. So I'll be passing that, and heights of rows -1, C. Right? Similarly, we are going to do for our rows. Row plus plus. In this case, again we are going to do the same thing, but now we will have rows constant and column will be 0th column, and the other one will be columns -1, because this is the last column. And for the first column, it will be Pacific Ocean, and previous height would be heights of R, 0, as these are the cells which we are sending, and the other one will be Atlantic, and heights of R, columns of -1. So this is done. Once this is done, what we have to do, we have to iterate over all the rows and columns. We have to iterate over all the rows and columns, and we have to check if Pacific has this particular cell, and Atlantic also has this particular cell. If both of them have it, then we are going to push it into our results array, and it would be R, C. This part is clear so far. Now for every cell, so basically we have passed first row, first column, last row, and last column through these loops. So they have to go through the DFS process. So in this DFS process, what they have to do is, they have to iterate over all the 4 directions possible, right? If I'm at this particular cell, it has to go towards the bottom. It can go towards the right, it can go towards the left as well. So we just have to pass DFS R plus 1, C, visit, and previous height will be height of R, C. So we have 4 directions. I will just copy them. So it would be R plus 1, R minus 1, C plus 1, C minus 1. And before visiting it, before moving to the next all 4 directions, we also have to add visit.add of our current cell, so that we don't revisit it again. And then we have to add our base cases. If row is less than 0, or our column is less than 0, or row is greater than or equal to rows, or column is greater than or equal to columns, or visit dot has of already, if the row if the cell is already visited, we don't have to revisit it again. So in that case, we are going to return, and if the previous height, current height would be height of r comma c. If it is less than the previous height, we are going to return. These are few conditions where we have to return, otherwise we can continue. Let's try to run it up. Cool, 1 second. Okay, this should be having a arrow function. This should be heights of r comma c. Okay, I think let me change heights. So this should be working fine now. There were some typos with respect to variable naming. It submitted successfully. So the hack here is, instead of moving from a cell to Atlantic Ocean or Pacific Ocean, we will have our first row and first column already, like every cell in the first row and first column will already be flowing to Pacific Ocean, and the last row and last column will already be flowing to Atlantic Ocean. So from every row, like first row, last row, and first column and last column, we try to check which all cells we can reach from there. Once we get to know that, we will take the cells which can reach both Pacific and Atlantic Oceans, and that will be our answer. I hope the solution is clear. Now let's try to also understand the time and space complexity of the solution. So time complexity of this solution would be big O of m cross n, because here we are doing m cross n. This is m, let's say this is n, so m plus n, and this will be big O of constant time, because it will at max, like the entire for loop and the DFS, entire for loops, these two for loops and DFS will reach all the cells at max once, because we have this condition, it will reach at max once, so it will not going to go beyond m cross n. So that is the reason it will be m cross n. And the space complexity would be big O of m cross n as well, because we are going to have a result array, and it might have all the cells which are reaching to both the oceans. So in that case it would be possible, and same thing with Pacific and Atlantic Ocean. If all the cells are reaching, then they will also have all the cells in the set. So yeah, so that is how we get time and space complexity. And one thing which we reversed condition here is that the condition they have given is that less than or equal to the current cell, but we are having a reverse check here because we are flowing from our Atlantic and Pacific Ocean to the cell, so the order will be different. That's the reason we are having a different condition here, and rest all is simple and straightforward. Thank you.